Hey guys, Dr. Brown here, and tonight we have an integration problem. The integral of 2x plus 3 over 9x squared plus 6x plus 5. What to do with that? Hey, let's get after it. Okay, you know the tools. We talk about these all the time. U sub, trig sub, integration by parts, partial fraction, power reduction, long division, completing the square, and we're adding one more for this problem. We'll call it method of quadratics. Okay, Q. U sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square, and methods of quadratics. Okay, now in this particular problem, when I first looked at it, I thought, whoa, which tool to use? And I thought, well, let me just complete the square. Let me try something with that, maybe end up with a U sub, trig sub type situation. But the key to this one would be, wouldn't it be really cool? Let's take the derivative, for example, of the denominator. We're going to take the derivative of 9x squared plus 6x plus 5. Okay, take the derivative of that. 2 times 9, this is the general power rule. 2 times 9 is 18. X to the 2 minus 1 is x to the first power. Plus, this is x to the first. 1 times 6 is 6. X to the 1 minus 1 equals 0. X to the 0 is 1. 1 times 6 is 6. Okay, so that derivative is 18x plus 6. Wouldn't it be really cool if 2x plus 3 equals some multiple of this? Let's just make that happen. So let's let 2x plus 3 equal a times 18x plus 6 plus b. Okay, so if we distribute a to the inside, I have 18ax plus 6a plus b equals 2x plus 3. Now you'll notice there's an x term here and an x term there. So those have to be equal to each other. So 2x equals 18ax. If I divide both sides by 18x, that will cancel here. So a equals 2x over 18x. So a equals 1 over 9. Now then, 3 has to equal 6a plus b. So 3 equals 6a plus b, or 3 minus 6a equals b. 3 minus 6 times a, which was 1/9, equals b. So 6 over 9 is 2/3. So 3 minus 2/3 equals b. This is 3 over 1, so I need to change it to thirds, so it's 3 over 3. So 9 over 3 minus 2 over 3 equals b. So b equals 7/3. Okay? So a, let's write that here. A equals 1 over 9. B equals 7 over 3. Now if we were to go back and put that in, let's do that just to make certain. So a, 18 times 1 over 9x, so 18 over 9 is 2, so that equals 2x, plus 6 times 1 over 9 plus 7/3. 6 over 9 is 2/3 plus 7/3. That's 9 over 3, which is 3. So that's 2x plus 3. So what this means is the integral of, I'm going to replace this 2x plus 3 with 1/9 times 18x plus 6 over 9x squared plus 6x plus 5 dx plus the integral of b, which is 7/3 over that would be 7/3 over 9x squared plus 6x plus 5 dx. So this is 2x plus 3, and I've just separated those into two different integrals. Okay? Nothing fantastic so far, except I now have the derivative of the function over the function. So it's 1/9 times the natural log of 9x squared plus 6x plus 5. So that integral is already, it's gone. It really made it simple. So it's plus 7/3 times the integral, I'll pull the 7/3 to the outside, dx over 9x squared plus 6x plus 5. Now we've just used our Q tool, and now we're going to use completing the square tool. We'll have all kinds of tools in this one. So let's do that. Take 9x squared plus 6x plus something plus 5. Okay, I think I need to start writing smaller. Alright, matter of fact, I'm going to put a box around this so I don't lose it. That's part of the answer. Okay, and because we're going to come over here and work this part, I think. We're going to pull out, if you don't mind, we'll work it here. 7/3 integral of dx over 9 times x squared plus 6x over 9. I've just pulled the 9 out, plus something plus 5. 6 over 9. Now you know, completing the square, you take the, you have a, b, and c terms inside on the second order quadratic equation here. 6 over 9 is 2 over 3. So we're going to take that and divide it by 2, which is multiplying by 1/2, and square it. So that's 1/3 squared equals 1/9, and that becomes this term right here. Now then, it's within the parentheses 9 times that 1/9, so I'm adding 1, so I need to subtract 1. So I now have 7/3 the integral of dx over 9x squared plus, if the 9's cancel here, plus 6x plus 1 plus 5 minus 1, which is 4. Now when you're trying to make the squared terms, you take the square root of the first term and the square root of the last term. So the square root of 9x squared would be 3x. Square root of 1 is 1, and look at that term here. If that's a positive, I can say that's plus. If it's a negative, it has to be a negative. So 3x plus 1 squared plus 2 squared. Now you'll notice at this point, if I were to let u, we're going to use another tool here, let u equal 3x plus 1, du equals 3 dx, du over 3 equals dx. So I have 7/3 times the integral dx is now du over 3 over u squared plus, and we'll let a squared equal 4, a equals 2. So this is a squared. It's at this exact point where your teacher is probably going to say, you should recognize 7 times 1 is 7, 3 times 3 is 9, so that's 7/9. And the integral of du over u squared plus a squared is 1 over a tangent inverse u over a. So in this case, 7/9 times a was 2 times 1/2 tangent inverse of u, which is 3x plus 1, over a, which is 2. So I've got 7/18 tangent inverse 3x plus 1. Wow, it looks terrible. 3x plus 1 over 2 plus c. Now then, I'm 66 years old as of this video, okay, and I probably might not remember that that is tangent inverse of these things. So hey, let's figure it out. And I love to do this. Okay. All right, let's take a snapshot. So let's see, what can we divide out here? Let's just work right in this area. Okay, so let's see. We're saying 7/18 tangent inverse 3x plus 1 over 2 plus c. That's what we're saying we're trying to get. All right, so let's do a trig sub. Wow, we're going to have 4 out of the 8 tools. All right. Let's wipe out a little something here, and we'll just get rid of that. Oh, I should have left that. That's my integral. Anyway, we know we're supposed to end up with that here, which is what we're working on. All right, so let's say we have a squared equals 4, a equals 2, u, let's let u equal a tangent theta. Now the reason for that is you have tangent squared plus 1 equals secant squared. So this is in the form like that. Okay, so remember a squared equals 4, a equals 2. If u equals a tangent theta, du equals a, remember the constant rule, we pull the constant out, the derivative of tangent theta is secant squared theta d theta. Okay, what do we want to do here? We have 7/9. 7/9 times the integral of du, which is a secant squared theta d theta, divided by u squared. And what did we say u was? U is a tangent theta. If I square that, that's a squared tangent squared theta plus a squared. So 7/9 times the integral of a secant squared theta d theta over, I'm factoring out the a squared term. Okay, a squared times parentheses of tangent squared theta plus 1. So I can reduce a few things here. A divided by a squared gives me a integral of secant squared. And what is this? Tangent squared plus 1? It's secant squared. So secant squared divided by secant squared is 1. 1 times d theta is d theta. So I have 7 7 over 9a theta. Okay, let's put our triangle together here. We have theta that's there. We said u divided by a would be tangent theta. So u over a is tangent theta. What does that give me here? That's a squared, well, u squared plus a squared. And a was equal to 2. And u, let's go back to our original u, was 3x plus 1. Now then, I have 7 over 9a theta, and theta is tangent inverse u over a. And that's u, remember, was 3x plus 1. And a is 2, so 9 times 2 is 18. So 7 over 18, tangent inverse of 3x plus 1 over 2, plus c. That's what we were trying to get. Okay, that we used what tools? The method of what I'm calling the method of quadratics, where we're trying to set the numerator equal to some multiple of the derivative of the denominator. That's the key factor there. Okay. Oh, we're not finished yet. Sorry. Okay, that is what goes in this box right here. So that's plus 7/18 over tangent inverse 3x plus 1 over 2 plus c. So the entire problem then, the entire answer is all of this. That's the results of that integral. Again, by methods of quadratics, u sub, trig sub, well, quadratics, completing the square, then u sub and trig sub. So we went through a lot of different worlds there. But that, my friend, is the results of that integral. Sorry for the big mess here. But again, your teacher probably wants you to recognize that that integral, the integral of du over u squared plus a squared, that integral is 1 over a tangent inverse u over a. So there's a few special integrals, that's one of them. So I would assume from a test perspective, trying to have speed on a test, you do need to recognize that. But at my age, I forget it, and I just know how to work it out. Okay? Why are we doing this? We're not crazy. We're just trying to build a better tomorrow and do that through math. Keep studying, okay? And we'll talk to you next time. Thanks.